Let V be the vector space of all 3 by 3 matrices with complex entry over the real field. If W1 defines all those matrices coming from the vector space and satisfying the property A equal to A conjugate transpose, and W is all those matrices having trace equal to 0, then the dimension of W1 plus W2 is equal to, and this conjugate transpose A bar T, denoted by A bar T conjugate transpose. So we have to calculate it, the dimension of W1 plus W2. Dimension of W1 plus W2 can be find out by the formula dimension of W1 plus dimension of W2 minus dimension of intersection, minus dimension of intersection. So we have to calculate it, all these dimension, and put in this formula that will give out dimension of W1 plus W2. And what is dimension? Dimension is number of times or at how many places you are free to choose or adapt values from the field. So if matrix A, suppose this is a matrix A comes in vector space V, then size of matrix A will be 3 by 3, and its elements will look like A plus iota B, where A and B, these are coming from real field. So there are total 9 entries. Total are 9 entries for every vector, for every matrices coming in vector space V. Now for W1, suppose this is W1, which is Hermitian matrix, and for Hermitian matrix diagonal entry are real numbers, and above the diagonal or principal diagonal you are free to choose any complex entry. So suppose this is my first, here is last entry, or can be denoted by A3, ij is 33, A33. So this A33 is real entry. So above this one there is 1, and use a square for complex entry and 0 or circle for real entry. So here will be 1, and here 2, and this one will be real entry. So this is the format, and below the diagonal entry will be transpose, conjugate transpose. So at how many places you are free, at how many places you are free, for each complex entry you are free at two position, because each entry will look like A plus iota B, and these A and B are coming from real field. So 2 into 4, 4 into 6, 6 position are here, and 3 position here. 6 and 3 total are 9. So dimension of W1 is 9. Now check dimension of W2. For W2 having the property, all those matrices having trace equal to 0, and these matrices are coming from vector space, so it will be size of 3 by 3. And for trace, what is trace? Sum of all diagonal traces. Trace of A will be sum of diagonal elements, sum of diagonal elements, and entry is coming from complex, and entries are complex, so it will be diagonal entries, suppose a plus iota b, c plus iota d, and a plus iota f. Now sum will give you a plus c plus e plus iota b plus d plus f, and this will be equal to 0 because of it is given to us trace of a is equal to 0. It means real part is 0 and imaginary part is 0, so a equal to minus of c plus e and b equal to minus of d plus f. Now these a and b are linear combination of c and e and d and f respectively, so these are linearly dependent. A and B are linearly dependent. It means this depends on what entries you are choosing here, C and at position E, respectively D and F. So there are two real entries. So you are not free at this stage. So because of you need only trace should be equal to 0. So total entry is 9. Total entry is 9. Left diagonal entries first. So remaining entry will be 6, and take double because of for each complex entry you are free at two places for choosing real part and imaginary part. 6 to the 12, so 12 entries at 12 position you are free, and and two entries from diagonal, two entries or two position you are bounded, and in diagonal total entries are 3. Total entries are 3. So it should be 3 to just 6 entry we should to free, but we are bounded at two place, so 4 entry here. So coming 4 entry, 12, 12 plus 4 16 entry, or 60 at the 16 position you are free to choose any value from the field. So dimension of W2 is 16. So dimension of W2 is 16. Now we will find dimension of intersection. How to find dimension of intersection? It means to find dimension of intersection, matrix will satisfy property of W1 and W2 together. Dimension of W1 and W2, first check what matrices are coming in intersection. All those matrix A such that matrix is Hermitian. So matrix A is Hermitian and trace of A equal to 0. These two properties matrix is satisfied together. For Hermitian, we already know at how many position we are free. You can check here. We are free at 9 position. We are free at 9 position. So this intersection, dimension of intersection will come less than 9. So we are free at 9 position. 9. And for trace at how many place? Or you can, for better understanding, this is 3 by 3 and these two entries are complex or shown by square, and these entry by circle are real entries. And for skew symmetric matrix, entry below the diagonal will be same. So at how many place you are free? These are 6 position. 3 square means 6 position you are free. So total 6 position coming from here. And for trace should be 0. Trace should be 0. There 2 entry will be. So 6 plus 2 total are 8 entry. So dimension of W1 intersection W2 is equal to 8. So dimension of sum W1 plus W2 will equal to dimension of W1, which is 9, plus dimension of W2 16, minus dimension of intersection 8. So dimension is 9 plus 8 equal to 17. Remember this point. These circle entries are real entry. So at 3 position you will be free, but for trace should be equal to 0. So suppose you are 3 entries. Suppose a plus b plus c equal to 0, then a equal to minus of b plus c. So you are free to choose b and c entry and any 2 entry. You are free you are free at 2 position, and third entry will be the negative of some of these first 2 chosen by you freely. So I took 2 here. You can understand better. So dimension of this one, sum of W1 plus W2 is 17.